Okay, let's do an alternate method to find polar coordinates. Say we're given the radius is 5, the angle is 2 pi over 3, and we have to stay in the restriction of negative 2 pi up through 2 pi. First thing I'm going to do is change my restriction so that I can match it with the fractions I'm going to get. So I want it to be in thirds. So I'm going to say that I have negative 6 pi over 3 is less than 6 pi over 3. And that'll be easier for me to compare. So make two different lists. List 1 is going to be angles that are coterminal with 2 pi over 3. So things that are coterminal with 2 pi over 3 will come from adding 2 pi or subtracting 2 pi. But since 2 pi over 1 is harder to do, I'm going to go ahead and write it as 6 pi over 3 and negative 6 pi over 3. So that means we'll have 8 pi over 3 and 14 pi over 3. We could keep going, but we're not going to need more than 2 in each direction, so I'll just stop there. And subtract 6 would be negative 4 pi over 3 and negative 10 pi over 3. Again, the list is continuous, but that'll give us enough. So now we need a second list of angles. We need a list that would be going in the opposite direction. So going in the opposite direction in radians would mean that I need to add pi. Adding pi in this case is going to be 3 pi over 3. So I'm going to take my original angle. I'm going to add 3 pi over 3, which gives me 5 pi over 3. Then I'm going to need to do the same thing as I did before, which is find coterminal angles. So I'll go in either direction. I'm going to add 6 pi over 3, which again is really just 2 pi. And then I'm going to subtract 6 pi over 3, which is really just 2 pi. Just get some coterminal angles. So 6 plus 5 is 11 pi over 3, plus another 6 would be 17 pi over 3, and subtracting 6 would give me negative 1 pi over 3 and negative 7 pi over 3. So my original angle was 2 pi over 3. The angle going in the opposite direction would be 5 pi over 3. And then I'm going to make a list of coterminal angles and another list of coterminal angles. And then I'm going to go back up here and I'm going to say, okay, which ones fit within our restriction? So our restriction, when I list it in thirds, is anywhere from negative 6 pi over 3 to 6 pi over 3. So I'm going to look at list 1 and I'm going to say, hey, these are the two that fit in that restriction. And then in our second list, these are the two that fit in that restriction. Anything that's in our first list, the things that have a coterminal angle to the original angle, are going to have the same radius as your original angle. So my radius originally was 5, so I'm going to use another 5. and then I'll have my negative 4 pi over 3. But anything that's in the other list, the second list, is going to have the opposite radius. So the two that we're picking are going to be these two, and they both will have an opposite radius. So I had a positive 5, now I'll have a negative 5. I have negative pi over 3 and negative 5 pi over 3. So we'll try that again with a different angle and a different quadrant. So the plan is to go ahead and make two lists. List 1 is going to contain my original angle, so I have a 11 pi over 6. And so in order to compare, when I go to do that, it's going to be easier if I go ahead and I'm going to put it a little higher this time so it's not running into my other numbers. Change my restriction so that it has a matching denominator. So I'm going to look at negative 12 pi over 6 all the way up to positive 12 pi over 6. And that's just a common denominator, so it's easier for us to compare. So how many numbers do I need to make in the list? As soon as you recognize which way is going to be helpful, you don't need any extra. The most you're going to need is 5 angles in this list. But I'm already at the top of this restriction. If I add anything more to that, it's going to just go outside the restriction. So I'm really just going to look to this direction, which in order to find coterminal angles, I'm going to need to go negative 2 pi, which I'm going to go ahead and write as negative 12 pi over 6. So that means I'm looking for negative pi over 6. If I thought I needed more, I could keep going, negative 12 pi. So I'm already noticing that that's beyond my restriction, so that one's not even going to be helpful. But it's okay, because I found 2 of them that are in that restriction. So it was the original angle and one more. So I'm going to need list 2. List 2 is going in the opposite direction. So the opposite direction means that I'm going to add, I could subtract, but I'm going to go ahead and add pi just to be consistent, which again is 6 pi over 6 this time. I'll have a different denominator. So I'm going to add 6. I have 17 pi over 6. And you might already notice that that is higher than our restriction. So for sure we're going to need to go below. How do I do that? I subtract 12 pi over 6. So 17 minus 12, 5 pi over 6. 5 minus 12, negative 7 pi over 6. We could keep going, but we have 2 in that list that are in our restriction, somewhere between negative 12 pi and positive 12 pi. That's these 2. So anything in the original list will have the same radius as our point. So we had a negative 3, so that means I'm going to have another negative 3 for my radius. I already used 11 pi over 6, so we'll use negative pi over 6. And so anything in the second list is going to have the opposite radius. So I had a negative 3, I'm now going to have a positive 3. And then I'm going to use either one of the angles, 5 pi over 6, and then use that radius, which is opposite from the original point. It's positive 3 and negative 7 pi over 6. One more. What if I have a negative angle? And I'm looking at fourths this time, so I'll write this as negative 8 pi over 4 and and 8 pi over 4. So my original list is at negative 5 pi over 4. So I'm going to subtract negative 8 pi over 4 and add 8 pi over 4. Again, really I'm just adding and subtracting 2 pi. And I'm doing that to find coterminal angles. So everything in list 1 will be coterminal to negative 5 pi over 4. So that would be negative 13 pi over 4. And notice, that's already too small. So let me go in the other direction. So negative 5 plus 8 is 3 pi over 4. I have 2. I'm just going to stop. Whenever I find that I have 2, I'm not going to get any more than that, so I can stop. So list 2 are things that are going in the opposite direction. Angles that have a ray going in the opposite direction means that I'm going to add pi, which in this case will be 4 pi over 4. So if I take my original angle and I add 4 pi over 4, I'll have negative pi over 4. And again, depending on what you see right away, you're going to be adding 2 pi, which is the same as adding 8 pi over 4, or subtracting 2 pi, which is the same as subtracting 8 pi over 4. But I'm already at negative pi over 4. So I really don't want to subtract 8 pi over 4. It's going to go beyond my restriction. So now I'm going to just add 8 pi over 4. And I'll get 7 pi over 4. So if you start to get the pattern of how this is working, you might be able to just come up right away with your initial 4 angles. So all 4 of those angles would be ways to represent the same coordinate. If I go back to my original list, that has my original angle. So again, I'm going to use the same radius. And that radius was 2. I've already used that angle, so I'll use 3 pi over 4. And in this other list, it's going in the opposite direction. So I'm going to want an opposite radius. So the opposite way would be negative 2. I'll go ahead and list both of these one at a time though. So I have negative pi over 4. And we'll continue using the negative 2 with 7 pi over 4. Okay, hopefully that works for you.